Hello guys and girls, this is T-Rex reporting back from the California Nebula. As you may know from my posts recently on Facebook that I have embarked on my 1,000 light year trip to the California Nebula, and I have recently just arrived at my destination, and look how beautiful that is. I am sitting at the heart of the nebula in the system California Sector BA-AE6, which will be the main character of our story today. So first, let's take a look at where we are in the galaxy in relations to our own human inhabited bubble. So I've typed in our solar system and it shows a distance of 991.81 light years, and if we zoom out to the galactic plane we can see that what happened there? Let's zoom out again. So you can see that I am quite a distance apart from the human inhabited bubble, which is about around 1,000 light years away. So anyways, let's head back into the California Nebula. You can see it is ruby colored, as I've shown in many of my photos I posted on the Facebook page. So let's get right into the system map. So the main star in California Sector BA-AE6 is an M-class star. It is very abundant in our galaxy, and I am not going to talk about it because it is not what makes this system stand out from the others. It is the planets. So let's first talk about the two belts that are present in the system. The A belt is a rocky belt. You can't mine from these kind of belts, but you know, you can always take some good scenery shots. And this belt is basically like our own asteroid belt. And we can see a farther belt that is about has a semi-major axis of about 1.18 AU. So that's about Earth's distance, a little bit more than Earth's distance to its sun. So it is an icy type belt, so you can't mine there as well. I guess these two belts are basically for exploration uses only. So let's take a look at the planets. So the first four planets are all the first five actually are all high metal content worlds, and the first four are without atmospheres. But the fifth one is it has a very thick carbon dioxide atmosphere, which makes this planet white as it is. You can see on the system map here, and the same atmosphere is present on Venus in our own solar system. That's why it is so white in its appearance. But all of the first five planets are not what we are going to talk about today. We are mostly going to focus on the last two planets over here. So planet 6 is a water world. I've talked about this in one of my previous videos, but I guess I'll just mention it again. Water worlds are planets that are mostly composed of water. You know, it's pretty simple. I'm not sure why the composition here says 67.3% rock and 32.7% metal, because I guess either the statistics are wrong or it shouldn't be classified as a water world, but since the system tells us it is, I will assume that it actually is. So water worlds are basically planets that should be composed of more than 90% water, and basically the whole planet is a vast ocean that's thousands of miles deep, and at the heart of the planet there is a core, but on top of the core, because the water is so compressed under so much pressure from the water above, it forms a unique form of ice called Ice 7. You can check that up on the internet if you want to. I will not go into that further detail, but it is a very interesting isotope if you are interested. Another exciting thing to note is that this water world actually has about 1 Earth mass, and its radius is also equal to that of Earth's. Also, its surface temperature is really nice, about basically 0 degrees Celsius. That is, I would say that is pretty good. So, and people might actually move in one day on this planet if there is land indeed, like it says in the composition right here, as it says 67.3% rock. So maybe it'll be a future home for human settlers. Who knows? So the 7th planet is the most interesting of all in our tour today. So it is an ammonia world. So ammonia is as you all may know, who took, especially those of you who've taken chemistry in high school or college, it's NH3. So one nitrogen atom and one nitrogen molecule and 3 hydrogen molecules bond together to form this gas. It's colorless, but it smells really bad. If you've done lab experiments with it, it smells really, really bad. So I imagine if you're living on this planet, you will have to wear some kind of gas mask and at all times, because the smell is just unbearable. So it does say it is a terrestrial ammonia world with an active ammonia-based chemistry and carbon ammonia-based life. So there is I assume some single cell life on this planet already, and it might be a potential planet where humans can actually settle on, but that'll have to be after the humans have managed to change its atmosphere type, because you can see its atmosphere is composed of 91.5% nitrogen and 8.4% argon, and none of these we actually need for our breathing. We need oxygen, right? We need oxygen. So we will have to terraform this planet in order to live on it. So that is very interesting to note right there. And this planet is actually I guess you can call it a super Earth, because it does have it does have 4 Earth masses and a radius of about 12,000 kilometers. So that's slightly bigger than Earth, but I guess it is still terraformable. And I just felt like this is because Ammonia Worlds are really rare in the Elite Dangerous universe, so I might think I'll give you guys a scenery look at it. So let's go back. So I am parked on top of this Ammonia World right now. You can see that this whole world is covered in a brownish color. Ammonia is supposed to be colorless, so I'm not exactly sure why it turns out to be a brownish color. I'm assuming because of the maybe sun ray refractions in some of the in its unique atmosphere might cause this type of color. But you can see it is very interesting. And you can see oceans and lands are very distinct on this planet as well. Also, you may have noticed on the system map that the other water world we talked about also has an ammonia atmosphere, and I'll just show you that, I guess. And it also occurs to have a brownish appearance like the one we are visiting right now. So I guess that's a typical thing when you have an ammonia atmosphere. And one more thing I forgot to talk about is you can see the surface pressure here. It's almost 707 atmospheres. If you were living on this planet right now, you will be squished to a flat, I don't even know what, because compared to this, the deepest part of the ocean on our planet, which is our planet Earth, of course, is a part of the Pacific Ocean that is called the Mariana Trench. And if you go to the deepest place of that trench, the pressure you get is about around 1,000 atmospheres. But that's the deepest place you can go on our planet. And you got to realize that the surface pressure measured here must be an average of the surface pressure on this planet. So if you stand on the surface of this planet, you are literally standing 2/3 of the way on your way to Mariana Trench. So it is really ridiculous to think about how humans might, terraform this place to some place we might live in the future while it's so hazardous right now. So many of you with keen eyes might have noticed the red glowing, on top. That is due to the effect of the California Nebula. That's right. So if you ever go into the heart of a nebula and you keep far away from the stars so that the star's brightness doesn't obscure these cool effects, you can see the effect of these nebulas, and they are just absolutely amazing. So anyways, guys, I will keep exploring around in the California Nebula, and I will bring you guys more star system spotlights to come. And I'll thank you for watching, and please don't forget to submit your cool screenshots to starsystemspotlights@gmail.com. I will select them for the Daily Wonder section. And this is T-Rex signing off.